Welcome back to coterminal angles. This time we're going to be using radians. And I did give you a note sheet for coterminal angles for radians. I gave you one for reference triangles and one for coterminal angles. But that's okay. We wanted to use it all for the radians. I think very quickly you got the idea on the degrees. I want to use them for radians. All right, so coterminal angles using radians. Two angles are coterminal if they have the same initial and terminal sides, right? So 0 and 2 pi, for instance, are coterminal, right? Because 2 pi, so 0 means I didn't go anywhere. 2 pi means I went all the way around the circle. Right? I'm going to end up in the exact same location. So we added and subtracted 360 degrees. Well, 2 pi is 360 degrees. So for coterminal angles in radians, we're going to add and subtract 2 pi. Right? So same idea, you're just adding and subtracting 2 pi. Right? And our circle is going to look a little different. The other one had degrees. This one's going to have radian measures. Now yours has all the values in here, but I did not start, and it has all the degree measures as well. You have degrees and radians, but I did not start off that way, and I drew this one. Right? So I gave you one that I had found. I drew this one in. All right, so we're going to go step by step. Right? So we have 0 and 2 pi. Right? That means you didn't go around the circle, you went all the way around the circle. Pi halves, which is the same as 90 degrees. Pi, which is the same as 180. 3 pi halves, 270, and then of course you're back all the way around again, 2 pi. Right? So those are the ones I told you should definitely remember, 90, 180, 270, and 360. All right, so let's add some more. So we can see where they are. Well, let's divide all of the quadrants in half. Right? So if one quadrant is pi halves, then half of pi halves would give us pi fourths. Right? So there's just things on the side there to help you figure stuff out. Right? And some important things. So 1/2 times pi halves, that's where I got the pi fourths from. If I add 1/2 and I add a fourth to it, I'm going to get 3 pi fourths. And then if I add 1 and add a fourth to it, I'm going to get 5 pi fourths. 3 pi halves is the same as 6 pi fourths. So 6 pi fourths plus another fourth is going to be 7 pi fourths. Right? And then if I go all the way around, 2 and 8 pi fourths is the exact same thing. Right? So we've added in the fourths. Let's add in some more important measures. And it's going to be, come on. Right, the thirds, right, and we're going to add, actually we'll add the 6. So we've added the thirds and the 6 here. All right, so on either side of pi fourths, we have pi 6 and pi thirds. So we're the least common denominator for 3, 4, and a 3, 4, 6, and 2 is 12. They're all divisible by 12, right? So 0 is 0. Right? So pi 6 is the same as 2 pi 12ths. Right? 3 pi 12ths is pi fourths. 4 pi 12ths is pi thirds. So essentially, we're counting by 12ths here. Right? And then there's no 5 pi 12ths. But 6 pi 12ths gives us pi halves. 8 pi 12ths, now we're in the second quadrant. That's 2 pi thirds. 9 pi 12ths is the same as 3 pi fourths. 10 pi 12ths is the same as 5 pi 6. There's no 11. Well, there is an 11, but it's not that important, and we're not going to be looking at 11. So I didn't graph an 11, but then I did graph 12 pi 12ths, which is the same as pi. Moving on, right? So we added one more 6. So I didn't put a 13, but I did put the next 6. So I only included 12ths that ended up being a 6th, a 4th, or a 3rd. Right? So 14 pi 12ths is 7 pi 6. 15 pi 12ths is 5 pi fourths. 16 pi 12ths is 4 pi thirds. There's no 17 on my graph right now, and I'm not going to put one. But 18 pi 12ths is the same as 3 pi halves. I didn't put in a 19. 20 pi 12ths is 5 pi thirds. 21 pi 12ths is 7 pi fourths. 22 pi 12ths is 11 pi 6. And then I didn't put in 23, but 24 gets us right back again. So I included only thirds, fourths, halves, and the 6, because those are important values. Remember at the end of, not the last podcast, the podcast before, when we were looking at how to change from degrees to radians, radians to degrees, I said that the thirds, the fourths, and the sixths are important because those are from our special right triangles. And we can have special right triangles in any quadrant. So that's why I have the thirds, the fourths, and the sixths. They all are values in a special right triangle, either in the first quadrant, the second quadrant, the third quadrant, or the fourth quadrant. I have the other angles that are up here are the quad angles. So those are our important angles, the special right triangles and the quad angles. All right, so now we have, and you already have it on there, so you don't have to worry about writing any of this down. But I did. But that's okay. All right, so now we're going to be graphing some. All right, so let's see how many I've got here, and then we're going to pick 2, or you pick 2. It doesn't matter to me. We've got 13 pi fourths. I just want you to have some practice. We have 13 pi fourths. We have 2 pi thirds. I have 7 pi fourths, and that's all I have. So I have 3. You can pick any one of the 3. Right? It doesn't matter to me. All right, so 13 pi fourths. All right, so let's think about how far we're going to go. So remember, 2 pi is all the way around the circle, right? So if I go 2 pi, which is the same as 8 pi fourths, I've gone around the circle 1 time. Actually, I'm going to, I want to be able to graph my negative in blue, so I'm not going to use blue. I'll use green. All right, so here I've gone around the circle 8 pi fourths, right? Because 2 pi equals 8 pi fourths. All right, so I still have to go another 5. Right? So, well, 4 pi fourths, that's 1 pi, right? Or just pi. We don't even need the 1 in front of it, pi. All right, so pi means I got to come all the way around to there. So far we've gone 12 pi fourths. We have to go 1 more. So this is 13 pi fourths right there. All right, so this would probably be a good one because this was a little bit more complicated to put in your notes. And you've got room for 2. 13 pi fourths, right? So that was 13 pi fourths. Right? Oops, except, that's a 6th, not a 4th. We should go to a 4th. So this is 4 pi fourths. We need 1 more. 5 pi fourths. I just decided to stop at the first line I saw. There we go. Now we're 13 pi fourths. All right, we need to go to a 4th. All right, number 4 would be halfway on our quadrant there. All right, so 1 positive terminal angle, I hope is really apparent. 5 pi fourths. Well, how could we get that one? All right, so the 13 pi fourths is what's graphed. That's the one in green. This is of course, our terminal side. Let me write that in. You write that in too. All right, so 5 pi fourths. Right, just went around the circle 1 time. Well, I'm not going to be giving you graphs that look like this so you can figure it out. You're going to have to calculate it out. But it's super easy. Let's calculate out one positive. So 13 pi fourths, if you haven't figured out, is already more than 2 pi. So since we're more than 2 pi, we could subtract 2 pi. 2 pi is a number the same as 8 pi fourths. And we'd still get a positive coterminal angle. We could find another positive coterminal angle simply by adding 2 pi. All right, so because 13 pi fourths is so large, whether we added 2 pi or subtracted 2 pi, we are still going to get a positive coterminal angle. 21 pi fourths is going to go around the circle. So 8 pi fourths is 1 time. It's going to go around the circle once, twice, and then go to that same location. Right? So I graphed the slightly easier one to graph, the 5 pi fourths, but let's write the other one in. It's not that 21 pi fourths is so difficult for me to go around the circle twice, but it's getting a little crowded on my circle. Let's graph the negative one. We already subtracted 8 pi fourths one time, and we still got a positive angle. Right? So if we take that coterminal angle and subtract 2 pi again, and remember 2 pi is 8 pi fourths. Got to have the same denominator to add and subtract fractions. We'll get the negative coterminal angle, which is negative 3 pi fourths. So all of these are coterminal angles, but now in radian measures instead of degree measures. So 13 pi fourths, 5 pi fourths, 21 pi fourths, negative 3 pi fourths. Those are all coterminal angles. They all start and stop in the exact same location. So this one I want you to graph. And then I guess we'll graph the next one because the 7 pi fourths is another fourth. So we should do something besides fourths in your notes. Right? There are an infinite number of coterminal angles. You just keep adding and subtracting. 360 if you're in degrees, 2 pi if you're in radians. You can do it a million times and have a million coterminal angles, but you might be tired. Let's do 2 more. 2 pi thirds, right? So 2 pi thirds, right, is pretty easy. We see it right there. Right there's 2 pi thirds. We didn't have to figure anything out. So gave you the hard one. Gave us a hard one for us to start with. So this is the initial side, of course. This is the terminal side, and this is 2 pi thirds. If we want to find a positive coterminal angle to 2 pi thirds, we're going to have to add 2 pi. Well, 2 pi is how many thirds? 2 pi is equal to 6 pi thirds. Right? It says we need a common denominator. So if we add 6 pi thirds to 2 pi thirds, we get 8 pi thirds, and that's a coterminal angle. So 8 pi thirds goes around the circle, oops, and it's going to try not to block the 2 pi thirds. There we go, let's jump over it. And then it goes to the same coterminal location. It just went all the way around the circle one time to do it, but it ends in the same location. To find the negative coterminal angle, we'll just subtract 2 pi. So 2 pi thirds minus 6 pi thirds is going to give us negative 4 pi thirds. We're going this way instead, right? So we have to go a full pi, that'd be 3 pi thirds, and then one more third, right? So one more third is going to bring us right here. That's a third, right? 2 pi thirds is a third, there's pi thirds is a third. That would be a third. Right? So that gives us negative 4 pi thirds. And that's all there is to graphing coterminal angles and radians. Right? How to find them, how to graph them. And if you have to graph them, I would label some key points on my graph, so just like I have here, so that it makes it a little easier. The more you add, the easier it is, right? One last one, 7 pi fourths, right? So a 7 pi fourths is pretty easy to find since it is right over here, right? So it's going to be halfway between 3 pi halves and 2 pi. Right? It's going to be in the fourth quadrant. Right? Each one of these quadrants is a fourth, is a half or 2/4, right? So one quadrant is 2/4, the next one is 2/4, and now we're 4/4. 2 more gives us 6 pi fourths, and then we need one more fourth, right? Just in case you were confused. All right, so this is the terminal side. Right, and that was 7 pi fourths. To find a positive coterminal angle, we are just going to add, and remember, 8 pi fourths was 2 pi, so we'll just add 7 pi fourths plus 8 pi fourths to give us 15 pi fourths. All right, so it just goes around the circle, all the way around. Keep on going, don't stop, jump over 7 pi fourths. There we go. Ends in the same location. It just went around the circle one time to do it. And then the negative coterminal angle, take 7 pi fourths and subtract 2 pi. and that's going to give you negative pi fourths. So right here, 1/4 of the way, right? Negative pi fourths. There is our coterminal angle that's negative. All right, and that's all there is to coterminal angles. I don't think those are too bad. And that's the end of this lesson. Thanks for watching.